Welcome to Science and Sleep, a small yet magical place where we walk together through the mysteries of the universe in the quiet and gentleness of the night. I am very happy that you have found this peaceful corner amidst the countless noises of the internet. Tonight, we will begin a journey both to explore and to relax, letting the mind soar in science while the heart calms in silence. If you wish to accompany me on the next journeys, please hit subscribe and the little bell so you won't miss out. And if possible, I invite you to stay until the end of the video, because sometimes the most meaningful moment lies in the ending, where we gently smile and drift into sleep. If we begin the journey right where we stand, a small planet orbiting an average star at the edge of a minor spiral arm, the first thing we recognize is the sense of vastness. The night sky, so familiar to human eyes, is only the outer shell of a story millions of times larger. The Milky Way is not a random faint streak in the sky, but a complex map woven from the light of hundreds of billions of stars, each carrying its own history. And the wonder is that, even though we have never had the chance to see our galaxy from the outside, with patience and imagination, humanity has been able to sketch its true shape. It is like standing inside a dark house with no windows, but simply by listening to echoes and observing the light leaking through cracks, you can imagine the size, the architecture, and even the inner structure of that house. With the Milky Way, we do something similar, measuring the distances of stars, listening to radio signals, observing the faint bands of dust. All of these are like small puzzle pieces, gradually forming a colossal picture. On this journey, we will travel from the most familiar regions, the cosmic neighborhood called the Orion Arm, where the solar system resides, out to the larger avenues of the galaxy. The Orion Arm is not a major spiral arm, but only a modest spur, yet it holds some of the most famous cosmic landmarks. The Orion Nebula, for instance, is not merely a faint patch in binoculars. It is a giant stellar nursery, where thousands of young stars have just begun to shine, like fragile candles lit in the darkness. Nearby lies the Pleiades cluster, or the Seven Sisters, a brilliant constellation enshrined in the legends of many cultures. To us, they are neighbors, but in the language of the cosmos, they are only a few bright specks along the edge of a greater road. From the Orion Arm, if we let imagination wander, we can gaze toward the galactic center. There, the Sagittarius Arm curves, rich with energy and filled with glowing nebulae. Looking through this arm is also one of the shortest routes to reach the core of the Milky Way. And at the very heart of that core, hidden behind massive clouds of dust, lies one of the most intriguing mysteries of the universe, a supermassive black hole with a mass millions of times that of the Sun. It is not only the gravitational anchor holding the galaxy together, but also a source of energy shaping the evolution of this spiral star system. But to get there, we must understand that the galaxy is not a static picture. It is always in motion. The spiral arms are not fixed bands of matter, but are more like waves on the sea, where gas and dust are compressed, collapsing into new stars. These arms are both cradle and graveyard, where stars are born and where massive stars explode as supernovae, scattering heavy elements across space. This rotation is at once chaotic and ordered, random and inevitable. If we could observe it from outside, we would see the Milky Way as a thin disk, about 100,000 light years wide, but only a few thousand light years thick. This structure makes it resemble a cosmic pancake with a bright bulge at the center. Beyond the disk lies a faint halo of stars, like home to ancient globular clusters that have existed since the dawn of the galaxy. Looking at them is like gazing into the oldest surviving memories, fragments that record a history more than 13 billion years old. It is difficult to grasp such immensity with ordinary language. Just traveling from the solar system to the galactic center takes 27,000 light years, meaning that light, the fastest thing we know, still requires tens of millennia to complete the journey. Compared to human history, when the light we see today left the galactic center heading toward us, Earth was still in the Ice Age and mammoths were walking the steppes. Yet what makes this galaxy special to us is not just the numbers. It is the stage where the entire human story unfolds. When we look up at the sky, we are not only seeing lifeless points of light, we are facing the very material history of ourselves. For the elements in our bodies, carbon, oxygen, iron, were all forged in stars that once lived, exploded, and seeded new generations. Every breath a human takes carries the imprint of stellar explosions billions of years ago. Thus, as we drift from the Orion Arm to the Perseus Arm, as we gaze at the radiant center or trace the ancient clusters in the halo, we are not merely exploring a distant galaxy, but learning to reread our own memoir. The Milky Way is at once home, memory, and a sketch of our future. And this slow journey, step by step, will reveal to us those layers from the gentle glow of young stars to the mysterious darkness of the supermassive black hole. If we regard the galaxy as a vast field, then the spiral arms are the fertile plots where the harvests of stars are continuously sown. One of these rich fields is the Scutum Centaurus arm. This is one of the major arms, stretching from near the central bar outward, spanning the inner disk of the galaxy. Here we encounter enormous star clusters shining as brightly as cities of light, the most remarkable being Westerland 1, a cluster so dense that hundreds of supergiant stars crowd into a space where, if the sun were placed, Earth's sky would never have known darkness. The Scutum Centaurus arm is so radiant that it outshines many other regions of the Milky Way. Yet, with the naked eye from Earth, we see only a tiny portion. Between us and that spiral arm, gigantic clouds of cosmic dust form a hazy curtain, hiding most of the spectacle. Fortunately, thanks to infrared and radio observations, that curtain has gradually been pierced, revealing a vibrant scene, where new generations of stars are still being born without end. Farther in, as we move into the innermost regions of the galaxy, we meet the Norma arm. It is less familiar, buried beneath thick layers of gas and dust. Yet even there, in the darkness, young stars ignite and clusters of newborn stars emerge. Norma is like a hidden seed vault, quietly nurturing the galaxy's future, reminding us that beauty and wonders always exist, even when we cannot see them directly with our eyes. The spiral structure of the galaxy is not an eternal statue, but a lively dance. Although each star freely wanders along its own orbit, the galaxy as a whole retains that graceful shape. This reality arises from a mechanism called density waves. The spiral arms are not fixed streams of stars, but rather regions of higher density moving across the galaxy, like ripples on the surface of the sea. When gas and dust enter those dense regions, they are compressed, triggering the birth of new stars. Thus, the arms are both nursery and graveyard, where supernovae end their lives, returning heavy elements to the universe. Imagine, the Sun and our planetary system are also drifting along in that great rotation. Every 225 million years, it completes one orbit around the galactic center, a galactic year, millions of times longer than human history. In that span, continents on Earth may drift, mountains may rise and collapse, and life itself may change its face. Each orbit is a long symphony of nature, of which we have only heard a few opening notes. But the galaxy is not only made of arms. Between those brilliant lanes are regions of seemingly empty space. In reality, they are not entirely void. There are still solitary stars, still faint dust and gas, only less radiant and less active. The spiral arms are like bustling boulevards, while the gaps between them are quiet alleys, yet both are necessary to create the galaxy's overall balance. As we move toward the center of the Milky Way, the scene changes completely. If the arms are the bright, youthful suburbs, then the center is the galaxy's old yet fierce heart. Hidden behind a colossal veil of dust, unreachable by the naked eye, lies a bulge stretching thousands of light years. It contains billions of stars, many of them ancient, carrying the memories of the galaxy's earliest days. At the very core of this bulge, like the nucleus of a giant cell, is Sagittarius A, a supermassive black hole about 4 million times the mass of the Sun. Usually, it is astonishingly quiet, emitting only faint light. But whenever a cloud of gas happens to fall in, it awakens instantly, tearing matter apart into a swirling accretion disk heated to millions of degrees, then blasting out violent jets of energy reaching tens of thousands of light years. These feasts are rare, yet enough to remind us that even in silence, the galactic center harbors a power beyond imagination. We know of the presence of Sagittarius A* not because we see it, but by tracking the stars around it. They race along curved orbits at thousands of kilometers per second, like dancers whirling around an invisible point. In particular, the star S2 has become a vivid proof of Einstein's general relativity. Its light is redshifted by immense gravity, and its orbit bends exactly as the equations predict. The galactic center, therefore, is not only a mystery, but also a natural laboratory for the deepest laws of physics. If we could stand near it, supposing that were possible, the sky would look like nothing on Earth. Stars would crowd together, their light so dazzling that darkness would seem not to exist. Gravity would bend light, creating strange arcs and overlapping images, like reflections in a giant warped mirror. At the center, the black hole would appear not as a hole, but as a round black shadow, encircled by a blazing halo. That sight, both terrifying and magnificent, is proof of the extremes nature can create. And yet, from the distant vantage of the solar system, we see only a peaceful sky. Each night, the Milky Way stretches across the heavens like a gentle band of light. It is easy to forget that behind it lie chaotic regions, massive black holes, stellar explosions, and endless cycles of rebirth. Our galaxy is at once a tranquil home and the stage for the most violent dramas in the cosmos. The Milky Way is not merely a beautiful spiral shape. It is the flow of life, the place where matter is created, recycled, and carried forward in new forms. From tiny stars quietly burning for trillions of years to superstars flaring and vanishing like fireworks, all contribute to that grand symphony. And we, small creatures on a blue planet, are also a single note in the song of the Milky Way. When we look deeper into the night sky, we realize that each star is not just an anonymous point of light, but a living entity within the flow of cosmic time. Their lives are like long chapters of a story, beginning with birth in cold clouds, growing into brilliant lights on the galactic plane, and finally fading away or leaving behind strange remnants. What is remarkable is that whether brief or lasting trillions of years, every star contributes to the endless symphony of the universe. In the main sequence phase, the longest stage of life, stars maintain a fragile yet steady balance. Nuclear fusion in the core produces energy pushing outward, while gravity pulls everything inward. This balance is so stable that, if observed with the naked eye, one might think stars are unchanging, shining eternally since the dawn of time. But inside, the cosmic clock is still ticking, gradually bringing them to the threshold of change. A small star like the Sun will spend billions of years in this stable state, providing light and energy for the planets orbiting it. But when the hydrogen fuel in its core runs out, it will expand into a red giant, a bloated, cooler, yet magnificent version of itself. In that moment, the sky around a planetary system will change color, the atmosphere flooded with soft red-orange light, as if the star's final flame is illuminating a farewell. Its outer layers will drift away into space, leaving behind a tiny, scorching hot core, a white dwarf, slowly cooling in silence over billions of years. By contrast, massive stars, tens or even hundreds of times larger than the Sun, choose a far more violent end. After exhausting their hydrogen, they plunge into a rapid series of fusion reactions, creating oxygen, carbon, silicon, and finally, iron. Iron is the stopping point, for it no longer yields energy through fusion. At that moment, gravity prevails. The core collapses in an instant, triggering a supernova explosion so powerful it can outshine the galaxy that hosts it. The remnants may be a neutron star no larger than a city, yet heavier than mountains, or a mysterious black hole from which not even light can escape. Neutron stars are so extreme that just a teaspoon of their matter would weigh billions of tons. Some spin at dizzying speeds, emitting beams of radio waves with clock-like precision. We call them pulsars. These cosmic lighthouses send regular signals across the vastness of space, allowing humanity to listen to the heartbeat of distant stellar remnants. There are also magnetars, with magnetic fields so immense that if one were placed near Earth, it could wipe electronic data from hundreds of thousands of kilometers away. They are among the most extreme machines ever created by the universe. If stellar remnants are proof of the violence of death, then nebulae are proof of rebirth. Stellar nurseries, immense clouds of gas, are both graveyards of old stars and cradles of new ones. The Orion, Carina, and Eagle nebulae all carry majestic beauty. Through telescopes, they appear as cosmic landscapes, towering pillars of dust, glowing waves of gas, vast cavities where stellar winds have swept matter away. Hidden deep inside, protostars are forming, like faint embers, waiting for the day they ignite. Imagine, within a seemingly still dark patch of a nebula, matter quietly gathers under gravity. When dense enough, a protostar is born, wrapped in a cocoon of gas and dust. Over millions of years, it draws in more matter, heating up until nuclear fusion begins, and a new star lights up the galaxy. This cycle never ends. The death of one star provides the raw material for the birth of another. Without these cycles, we would not exist. The iron in our blood, the calcium in our bones, the carbon in our bodies, all were created in stars that died long ago. When we gaze at the night sky, it is hard not to feel humble. Each of us carries the remnants of ancient supernovae. We are not only looking at the stars, we are looking at the source of ourselves. But perhaps what makes the Milky Way special is not only the dazzling giant stars, but also the countless faint, quiet ones, especially red dwarfs. They are so dim that the naked eye can barely perceive them, yet they exist in overwhelming numbers, forming the invisible backbone of the galaxy. They burn slowly, steadily, and can live thousands of times longer than the sun. In trillions of years, when the last massive stars have vanished, the faint glow of red dwarfs will still shimmer, sustaining the slow yet resilient heartbeat of the universe. At that scale, the time we experience, decades, centuries, is but a blink. Yet it is precisely this slowness that makes the universe an open, endless book. And every time we look up at the sky, we find ourselves reading another line, another chapter in a story that never ends, the story of the stars. When we speak of stars, we often think of lonely beings shining in the endless void. But in reality, most of them are not born alone. They come into existence in cosmic cradles, immense clouds of gas and dust, where hundreds or even thousands of sibling stars ignite together. These communities are star clusters, and they tell us another story, the story of connection, growth, and separation in the life of the Milky Way. Open clusters, young and radiant, are a testament to dynamism. They are often found along the spiral arms, where abundant gas and dust provide fertile ground for star formation. Now, within these clusters, we see all kinds of stars, from dazzling blue giants that live fast and die young, to tiny, quiet stars that burn for trillions of years. When we look at the Pleiades, the seven sisters, we don't just see a few sparkling blue stars, but a half-finished painting. Hundreds of other stars growing, some already drifting away from their family, scattering into their own orbits across the galaxy. In contrast, globular clusters feel like the elders of the universe. They are more than 10 billion years old, meaning they have existed since the Milky Way was still young. Imagine standing in the core of a globular cluster. The sky would no longer be a dark backdrop dotted with light, but a blazing dome filled with tens of thousands of suns packed tightly, each separated by only a few light weeks. Darkness would almost vanish, and you would feel as though you were standing in the middle of an eternal city of light. These clusters endure thanks to extremely strong gravitational bonds, yet even they cannot resist the slow erosion of cosmic time. Both open and globular clusters are treasures for astronomers. Since stars in the same cluster are born almost simultaneously from the same material, they act as natural laboratories created by the universe. By comparing the brightness, color, and mass of cluster members, scientists can reconstruct their history and even precisely estimate the cluster's age and the evolutionary speed of its stars. In other words, star clusters are collective journals written in light. But it is not only star communities that form the grand picture. Between stars lies another vital component, the interstellar medium, ISM. This is a tenuous mixture of gas, dust, and radiation, threading through the galaxy like a nourishing substrate for the stellar life cycle. If you took 1 cubic centimeter of the ISM, the number of atoms you could count might be no more than the fingers on a hand. Yet, summed across galactic scales, this mass becomes a vast raw material, enough to give birth to millions of suns. The ISM is mostly hydrogen, the fundamental brick of the universe, along with helium and small amounts of heavier elements. It is these heavier elements forged in the cores and deaths of previous stars that add the essential flavors of diversity. A molecular cloud rich in carbon, oxygen, and nitrogen may become the cradle not only of new stars, but also of potential planets, and further, of life. In other words, the ISM is the silent bloodstream, recycling the ashes of old generations into new life. Strangely enough, although the ISM is so thin as to be almost empty, it is far from quiet. Stellar winds from giant stars constantly blow through, compressing here, stirring there. Supernova explosions unleash colossal shock waves, squeezing matter into denser clouds, and from those clouds, protostars begin to form. This is the eternal cycle of rebirth. The violent death of one star can spark the birth of hundreds of others. Looking further, we see the Milky Way itself functioning like a vast recycling machine. Each galactic rotation, taking about 200 million years, is a heartbeat, sweeping clusters, gas, dust, and energy into an endless spiral dance. Within this dance, some stars are old and nearing their end, some clusters are just being born, and some interstellar clouds are silently preparing the next generation. All blend into a grand symphony where the end of one chapter is also the beginning of another. What makes this story special is this: we are part of it. Earth, the sun, and the human body all originated from these very processes. When we gaze at the night sky, we are not merely looking at distant specks of light, but confronting the deepest history of ourselves. It is a history written in hydrogen and iron, in explosions and rebirths, in the life cycles of stars unfolding over billions of years. Each time we look up, the sky may appear unchanged, but the truth is that somewhere in the galaxy, a star is flaring for the last time in a supernova, while elsewhere, a newborn star is just igniting in a dust cloud. The universe has never been static. It is always in motion, renewing itself and opening new possibilities. And when we connect these fragments, we realize the night sky is not a dead picture, but a living film, playing so slowly that the naked eye cannot perceive it. Perhaps this slowness is the true wonder. It allows us, beings who live for but a fleeting blink in cosmic time, the chance to observe, to reflect, and to find meaning. In the seemingly empty darkness, life is still nourished, light is still kindled, and the story of the stars continues. In the vast universe, it is hard to believe that the solar system itself, our home, is just a tiny traveler journeying on a colossal orbit around the center of the Milky Way. This voyage lasts hundreds of millions of years, so long that the entire history of humankind is but a blink of an eye compared to one complete revolution. Yet despite its slowness, the journey is not silent. It is an adventure through turbulent cosmic regions where the interstellar medium, spiral arms, and even hidden dangers await. In fact, the solar system is gliding at nearly 1 million kilometers per hour around the galactic core. At that speed, you could travel from Earth to the Moon in less than half an hour. But set against the enormous scale of the Milky Way, over 100,000 light years across, that velocity feels like a leisurely stroll. About every 225 million years, the Sun completes a single orbit around the galaxy. And what is fascinating is that each orbit takes Earth into entirely different regions of space. On this voyage, the solar system not only traces an elliptical path around the galactic core, but also oscillates up and down relative to the galactic disk, like a boat rocking on waves. This oscillation cycle lasts tens of millions of years, and each time we cross the galactic plane, we may enter regions richer in stars and dust. Such areas are often cradles of young stars, where massive molecular clouds condense and glow under ultraviolet radiation from giant blue stars. Passing through the spiral arms of the Milky Way is like traveling through bustling districts of a vast city. There, star density is higher, and processes of creation and destruction unfold more intensely. Beautiful as they can also be dangerous. Massive stars, living only a few million years, may suddenly explode as supernovae, releasing tremendous energy along with floods of cosmic rays sweeping through space. If such an explosion occurred too close, it could directly affect Earth, from weakening the ozone layer to altering the climate. Scientists have even wondered, could some mass extinctions in geological history be linked to our passages through the spiral arms? Though the evidence is still debated, the idea reminds us that life on Earth is not separate from the galaxy. On the contrary, it is influenced by the very cosmic environment we are drifting through. Sometimes, even small changes in interstellar dust density can impact the heliosphere, the bubble of solar wind that shields us from most cosmic radiation. If the heliosphere were compressed by a dense dust cloud, more high-energy particles could penetrate the solar system, indirectly affecting climate or even the pace of biological evolution. Yet, not every crossing of spiral arms is ominous. Sometimes they reveal more dazzling skies when Earth is surrounded by bright blue young stars, colorful nebulae, and magnificent clusters. During those stretches lasting millions of years, if one had eyes patient enough to observe, familiar constellations would change shape, replaced by entirely new patterns. The night sky, seemingly unchanging, is actually just a fleeting snapshot of an ever shifting dance. It is remarkable to remember that the stars we see tonight were not always there. A few million years ago, the night sky would have looked very different, and a few million years from now, constellations like Orion or Scorpius may vanish, giving way to unfamiliar arrangements. On this long journey, the sun also has temporary companions, stars moving near our orbit before gradually drifting away. The sky is an endless parade in which we are only brief spectators. This collective motion not only alters the scenery of the sky, it also plays a vital role in mixing the components of the Milky Way. As the Sun and countless other stars orbit the galactic center, gravity draws them into gentle interactions, gradually stirring gas, dust, and the heavy elements left behind by earlier stellar generations. Thanks to this mixing, the galaxy is continually enriched, evolving from an early universe of only hydrogen and helium into one abundant with carbon, oxygen, iron, the elements essential for rocky planets and life. What makes this journey poetic is that we can tell its story from our very position. On a small planet orbiting an ordinary star, humanity has invented science to measure speed, map trajectories, and even predict what lies ahead. Looking at geological records, we realize that Earth has traveled with the Sun through at least 20 galactic orbits since its formation. Each orbit has witnessed the rise and fall of civilizations, the appearance and extinction of species, and even the drifting of continents. If one day humanity can extend its existence across tens of millions of years, we will see the sky change with our own eyes, enter new stellar districts of the galaxy, and perhaps even learn to harness the energy of stars themselves to continue the voyage. But even if that day has not yet come, knowing that we are all adventuring together aboard a spacecraft called the solar system is enough to make every dawn and every nightfall more meaningful. For this journey does not belong to the sun alone. It is the shared journey of Earth, of oceans, of mountains, and of every living being on this planet. And when we look up at the sky, we see not only distant stars, but also the very path we are traveling, an endless journey across the Milky Way. When we observe the Milky Way, it is easy to mistake it for an eternal structure, standing still like a gigantic painting stretched across the universe. But in reality, our galaxy is like a living organism breathing, constantly changing through gravitational interactions with its surroundings. The satellite galaxies, from the bright Magellanic clouds in the southern sky to the faint dwarf galaxies only recently identified, all take part in a complex dance where gravity is the conductor. These very interactions have helped shape the Milky Way's present form while also revealing the larger story of how galaxies evolve over time. Take, for example, the large LM small SMC Magellanic clouds. From Earth, they look like two faint smudges, but in fact, they are entire worlds of their own with billions of stars, brilliant globular clusters, and immense stellar nurseries. The LMC contains the Tarantula Nebula, one of the most vigorous star-forming regions in the nearby universe. There, massive stars are blazing, releasing energy and radiation powerful enough to illuminate an entire vast region of space. These stars will soon end their lives in violent supernova explosions, scattering heavy elements throughout the interstellar medium, later to be used by a new generation of stars. If the LMC is a stage, then the tarantula is a firework display that never ends. What makes these clouds special is not only their intrinsic beauty, but also their gravitational relationship with the Milky Way. They do not merely orbit us, but also interact with each other, tugging out streams of hydrogen gas stretching across half the sky, the Magellanic Stream. That flow of gas is like an ink trace left on paper, recording a gravitational struggle that has unfolded over billions of years. Through it, we see that galaxies are not isolated islands, but interconnected entities within an invisible web, constantly influencing and transforming one another. The interactions are not always gentle. The Sagittarius dwarf galaxy is a clear example. This tiny galaxy has plunged through the Milky Way's disk multiple times on an extreme elliptical orbit. Each time it has lost part of its body, torn into long, slender streams of stars draped across the sky. These ribbons can still be detected in modern surveys today, curving as a memory trace of a catastrophic encounter. The story of the Sagittarius dwarf reminds us that the Milky Way does not simply stand still to welcome visitors, but grows by gradually absorbing its smaller neighbors. This process, known as galactic merger, is in fact the primary mechanism by which galaxies grow in the universe. On a cosmic scale, this is not an act of violence, but rather a natural process where the large incorporates the small, weaving together an ever more complex picture. The Milky Way itself is no exception. Its bulge, many of the globular clusters in its halo, and even part of the Sun's orbit carry the marks of ancient mergers. When we study faint stellar streams, astronomers are essentially reading the ancient diary of the galaxy, a book written in gravity and starlight. In this vast picture, dark matter continues to play a foundational role. The Milky Way's enormous dark matter halo holds these satellites tightly, like an invisible frame, allowing the entire gravitational dance to unfold. Without dark matter, the dwarf galaxies would easily escape, and the Milky Way would lose its source of fresh gas and stars to remain vibrant. In a way, dark matter can be imagined as the silent strings of an instrument that emit no sound, yet determine the melody of the entire galactic symphony. What is fascinating is that when we look further, we see that the Milky Way is not only a consumer, but also part of an even larger interaction. Far beyond the small satellites, the giant galaxy Andromeda is hurtling toward us at about 110 kilometers per second. In about 4 billion years, the two will collide, spiraling together in a grand union. That event will completely transform the night sky for the descendants of humankind, if they still exist. The current Milky Way will gradually be replaced by a chaotic tapestry of interwoven star fields before settling into a new, enormous elliptical galaxy. Such collisions do not destroy individual stars. The distances between them are too vast, but they will ignite bursts of new star formation, stirring life out of turmoil. Reflecting on all this, we see that the Milky Way's story is not a silent epic, but a turbulent journey where every satellite, every stellar stream, every merger is a chapter in an immense chronicle. And the wonder lies in the fact that we can reconstruct this history simply by observing the sparkling lights in the night sky. Each point of light, whether a star of the Milky Way or the remnant of a galaxy long consumed, whispers about a journey spanning billions of years. It is hard not to feel small before such a vision. Yet at the same time, it plants within us a quiet pride. We are part of that story. On a tiny planet, humanity has learned to listen to the echoes of invisible dark matter, to notice the faint stellar streams and understand that they are the backbone of a growing galaxy. More than that, we know that this story is not over, that ahead lies a great merger with Andromeda waiting to unfold. Meanwhile, the Magellanic Clouds still blaze in the southern hemisphere's sky. The Sagittarius dwarf is still being torn apart, and dozens of other faint satellites continue to orbit the Milky Way in silence. Looking at them, we see a simple lesson. Even what seems weak and small can leave a lasting mark on the journey of a colossal system. And along the endless road around the galactic center, it is precisely these interactions that have transformed the Milky Way from a primordial star cloud into the radiant home we know today. In the vast darkness surrounding the Milky Way, the dark matter halo and stellar halo embrace the galaxy like an invisible cloak, shaping its every silent movement. Though it does not shine and cannot be seen with the naked eye, the dark matter halo is the crucial foundation that keeps the entire galactic structure from falling apart. It is like the skeleton of a colossal organism. We never see it directly. Yet every motion, from the orbits of stars at the edges to the graceful shape of the spiral arms, reveals its mysterious presence. Thanks to dwarf satellite galaxies, disrupted stellar streams, and ancient star clusters, astronomers have gradually reconstructed the form of this invisible cloak. What is captivating is that the galactic halo is not merely a static structure. It is a reservoir of history, a chronicle written in starlight. Each globular cluster in the halo, each faint stellar stream stretching across the sky, bears the imprint of mergers that happened billions of years ago. The Milky Way was not born in a single moment, but grew through countless accretions. Smaller galaxies, such as the Sagittarius dwarf or faint remnants recently uncovered by Gaia, fell into the Milky Way's gravitational embrace, shredded and dispersed, leaving behind stellar streams like delicate scars in space. As we map these streams, we are rereading the evolutionary diary of the galaxy itself, a diary written in orbits and light rather than words. Yet the greatest mystery lies in dark matter. In measurements of the rotational velocities of stars at the edge of the galaxy, there is an anomaly that visible light cannot explain. If we only accounted for the mass of stars, gas, and dust we can observe, the stars in the outer regions should have already flown away, leaving the Milky Way's grasp. But instead, they continue to orbit faithfully, as if an invisible hand is holding them back. That hand is the gravitational field of dark matter, a component that makes up most of the mass, yet remains completely silent to light. Though we cannot touch it, dark matter is the foundation of the entire universe, determining how galaxies form, evolve, and endure across billions of years. Imagine the Milky Way as a vast growing city. At the center, the oldest neighborhoods, the stellar halo and globular clusters, are its earliest foundations. Surrounding them, the spiral avenues stretch outward like veins, where millions of younger stars are still being born. And encompassing it all is an immense belt of dark matter, like an invisible wall protecting the city from falling apart. This city never stands still. Stars move, spiral arms ripple, dwarf galaxies continue to be pulled in and assimilated. Even as we attempt to map it, the galaxy has already changed from the moment we first began to observe. Modern observations, especially from the Gaia mission, have opened a golden era for unraveling this history. With the ability to precisely measure the positions and motions of over 1 billion stars, Gaia has revealed hidden traces within the halo, enormous structures formed from mergers that occurred billions of years ago. Ripples in the disk, fragmented stellar streams, all point to the Milky Way as a dynamic system, continually reshaped by cosmic encounters. Like archaeology on Earth, astronomy is excavating layers of the past, but instead of digging into soil and stone, we work with light and orbits. The wonder is that by studying the galactic halo, we are not only learning about the Milky Way, we are also learning how the universe itself operates. Dark matter, hot gas, ancient star clusters, all are vital pieces in the broader picture of galaxy formation as a whole. Each newly discovered stellar stream, each chemically analyzed globular cluster helps refine cosmological models, bringing us closer to answering one of the greatest mysteries: how the universe was built from its earliest beginnings. And even though science today has made extraordinary progress, we have never truly seen the Milky Way in its entirety from the outside. We are confined within the very structure we study, like a fish in a pond trying to imagine the shape of the water that surrounds it. But perhaps it is precisely this limitation that makes the journey of discovery more poetic. Each new piece of the map not only provides data, but also sparks imagination. If we could fly outside, seeing the Milky Way as a spiraling flower of light in the darkness, how radiant our cosmic home would appear. The galactic halo, with its silence and mystery, is a reminder that what we see is only the surface of a greater reality. Behind every glittering band of starlight in the sky, there is an unseen framework at work. And perhaps it is this very invisibility that makes exploring the universe an endless adventure. When we gaze at the night sky, we are not only looking at stars, we are looking through time, touching living fossils from the primordial era and unconsciously connecting with a story far longer than human history. If the galaxy were a symphony, then black holes would be the mysterious bass notes, almost never raising their voice, yet giving the entire melody its depth. At the center, Sagittarius A Star, the supermassive black hole, is a silent conductor, controlling the orbits of millions of stars. But scattered across the spiral arms and the outskirts, millions of stellar mass black holes are like anonymous musicians, bursting into X-ray brilliance whenever the chance arises, only to quickly fall silent once more. The hunt for these invisible ghosts is one of the greatest challenges of modern astronomy. Stellar mass black holes are not born peacefully. They are the legacy of massive stars, many times larger than the sun, when they exhaust their fuel and collapse violently in a supernova explosion. That explosion can shine brighter than an entire galaxy for weeks. But after the glorious flash, all that remains is a dark gate, a place where space and time are warped so intensely that nothing, not even light, can escape. Yet, paradoxically, it is precisely this absolute darkness that helped scientists identify them, not by looking directly, but by observing the strange changes in the world around them. One of the most subtle methods is to track binary star systems. When a black hole has a companion star, its immense gravity can siphon material from the star's surface. The gas spirals inward at nearly the speed of light, heating up to millions of degrees Celsius and emitting powerful X rays. That accretion disk is like a ring of fire announcing the presence of the unseen. Space telescopes such as Chandra or NuSTAR can capture that light, revealing the hiding places of black holes. Sometimes, discovery comes with a touch of the ordinary. Take Cygnus X1, the famous stellar mass black hole, which was once the subject of a friendly wager between Stephen Hawking and Kip Thorne. Science in that moment became unexpectedly close and profoundly human. Beyond X rays, other methods also open the path to unmasking these dark travelers. By observing the tiny wobble in a star's orbit, astronomers can infer the presence of an invisible companion of immense mass. When the calculated mass exceeds the limit of a neutron star yet falls short of a supermassive black hole, the only answer is a stellar mass black hole. Gravitational microlensing, the bending of light when it passes near a massive object, also helps us detect wandering black holes unattached to any star. They are like drifters, silently swimming in cosmic darkness, leaving traces only by chance when they pass in front of a distant star. What is most captivating about black holes may not only be their physical mystery, but also their symbolic meaning. They are the ultimate endpoint of stellar life, places where time seems to halt and the familiar laws of physics dissolve. In imagination, falling into a black hole is stepping through a door of no return, but in science, it is a natural laboratory allowing us to test of general relativity and quantum theory. Each black hole, though tiny within the vastness of space, is an intellectual challenge for humankind. When compared with exoplanets, the contrast is striking. Exoplanets are promises, new worlds where seas, skies, and even life might exist. Black holes, on the other hand, are warnings of destruction, of absolute silence, the endpoint of a star's life cycle. Yet both, in their own way, complete the grand picture of the galaxy. One side is creation, the other annihilation. One side holds the seeds of life, the other the dying embers of cosmic death. The Milky Way thus becomes a full symphony, from the clear, bright notes of newborn planets to the dark bass notes emanating from black holes. The wonder is that all of this unfolds around us, within the very galaxy where Earth resides. When we gaze at the night sky, we may be unknowingly looking toward an alien planet still orbiting its star, or toward a black hole silently devouring nearby matter. They remind us that the Milky Way is not merely a quiet cosmic home, but a living ecosystem where life, death, and the deepest mysteries of physics intertwine in an endless dance. And the journey of discovery is far from over. Each new generation of telescopes, each technological breakthrough, promises to unveil another layer of the veil. One day we may capture a direct image of an Earth-like planet glowing blue dozens of light years away. Or, perhaps we will, for the first time, measure gravitational waves from the collision of wandering stellar mass black holes within the galaxy. Those moments will not only be scientific triumphs, but also proof of humanity's enduring aspiration, always reaching beyond the darkness to touch the light of knowledge. From this perspective, the Milky Way appears not simply as a galaxy of stars. It is a galaxy of worlds, of black holes, of mysteries. A galaxy that both nurtures life and reminds us of destruction, and above all, a galaxy of questions that each generation longs to answer. Perhaps it is this very truth that makes the night sky an inexhaustible source of inspiration. Each star is not just a point of light, but an invitation for humanity to continue its journey of discovery, a journey that has never ceased since we first looked up. When we step out under the night sky and lift our eyes to the pale band of light stretching across the heavens, it is hard to believe that within it lie hundreds of billions of stars, trillions of planets, and countless drifting black holes. Yet for most of human history, the Milky Way was not an astronomical concept. It was a symbol, a painting across the sky where human imagination could freely weave stories of origin, destiny, and life after death. If the galaxy, in the eyes of scientists, is the product of gravity and cosmic evolution, then in the eyes of ancient cultures, it was a road connecting the visible world with the invisible. The myths of Greece and Rome are clear evidence of this. Just a streak of light in the sky, and the Greeks turned it into a mythical stream of milk flowing from the goddess Hera, leaving an immortal trace upon the heavens. The Romans carried on that story but gave it a more social and political meaning, a radiant road through the cosmos, reflecting the stone-paved avenues stretching across the empire. In that view, the galaxy was both sacred and a mirror of human greatness on Earth. In the icy north, the Vikings and Scandinavian peoples did not see Hera's milk, but rather a bridge leading to Valhalla, the eternal home of fallen warriors. Those souls, leaving the mortal world, would walk upon the path of light toward endless feasting and battle. A distant streak in the sky in their eyes suddenly became a passage of honor, of immortality. In Finnish culture, the image shifted again. The Milky Way was the path of birds, a cosmic compass guiding migrating flocks through the dark of night. The connection between nature and the sky revealed itself in how humans sought to explain the mysterious behaviors of animals. Farther west, in Central America, the Maya gazed at that band of light and called it the cosmic river. To them, the sky was a mirror of the earth. The meandering rivers below had their reflections in the heavens. They even imagined the bright bulge at the center as the wide-open mouth of a giant crocodile, a symbol of both devouring and rebirth. The Inca, however, offered another interpretation. They did not only see the bright spots, but also paid attention to the dark spaces between them. The cosmic dust clouds that blocked the starlight became, in their imagination, the shapes of llamas, foxes, snakes, animals familiar to daily life. What science calls interstellar dust lanes became dark constellations in the minds of the Andes people, proof that humans always find meaning even in the shadows. All these diverse interpretations share one thing in common. They reflect the intimate relationship between humans and the sky. Before telescopes, before gravity or orbits were known, our ancestors read the galaxy as if reading an open book. They saw in it roads, rivers, mythical memories, and also practical guidance for journeys on Earth. Nomadic peoples of Africa or the Eurasian steppes used that glowing band as a compass for their migrations across vast deserts. Ancient sailors on the Mediterranean or the Pacific watched the Milky Way to navigate across the endless sea. For them, the galaxy was not only myth, but a tool for survival. Today, though we know that band of light is the combined glow of billions of stars in the galactic disk, its beauty and meaning remain undiminished. On the contrary, scientific knowledge seems to make it even more wondrous. For now we know that each point of light is a distant sun, each dust lane a trace of immense clouds where new generations of stars are born, and that the entire spiral structure is the product of more than 13 billion years of evolution, of galactic collisions, of gravity silently binding everything together. The Milky Way is both myth and physical reality, a bridge between ancient imagination and modern knowledge. What is remarkable is that whether through telescopes or the naked eye, we all see the same band of light and are driven to ask questions. The ancients asked, "What is it? Where does it lead? What does it have to do with the gods?" We ask, "How many planets are there? Is there another civilization looking back at us?" The questions change, but the longing does not. As if the Milky Way, through the ages, has become a mirror reflecting the human mind, fears, beliefs, hopes, and unending curiosity. Perhaps it is precisely this blending of science and myth that makes the Milky Way so special. If we look at it only through numbers, 100,000 light years across, 200 billion stars, it is mere data. But when those numbers are placed in the setting of a summer night, where a young person lifts their eyes for the first time and wonders, where do we come from? The data becomes a lived experience. In that moment, the galaxy is not just an object out there, but part of the human story. And that may be the most magical thing, whether in ancient Greece or the 21st century, whether Viking warrior or astronomer, looking up at the Milky Way always awakens the same feeling, the sense of standing before something greater than oneself, at once distant and intimate. It reminds us that the story of the galaxy is also the story of us. From stardust we were born, and one day to stardust we shall return. In the endless darkness of the Milky Way, the Drake equation is like a lamp, not illuminating the entire universe, but helping us recognize anchors to imagine the possibility of life out there. Though it does not give us an exact number, it sparks the imagination. If each factor holds within it at least some chance, then that vast field of stars could harbor thousands, even millions of civilizations. A thought both overwhelming and humbling, for we suddenly realize that perhaps humanity is not the only story the universe has written. Over the past decades, the Kepler telescope has opened a new era. The galaxy is no longer an abstract sky, but a map filled with worlds. From the data collected, thousands of exoplanets have been confirmed, and among them, many lie in the habitable zone, where liquid water, a crucial ingredient for life, can exist. What was once a hypothesis is now reinforced by evidence. Planets are not rare, but astonishingly common. The image of a Milky Way teeming with island worlds suddenly becomes more real, more tangible than ever. But life does not only require suitable terrain, it needs fragile conditions. An atmosphere to retain heat and protect, a magnetic field to shield against radiation, and enough time for evolution to unfold. We know this from Earth itself. It took nearly 4 billion years to nurture intelligence. So, in some distant corner, might there be a planet that progressed faster? A species that has surged ahead, using their own technology to look toward us as we are searching for them? That question makes humanity both small and great. Small because we are but one species in a vast galaxy. Great because even with limited capacity, we still strive outward, building projects like SETI, the search for extraterrestrial intelligence. Giant antennas pointed at the sky, listening for faint radio signals from space, with the hope that one day we might catch a call not from Earth. It is an act both scientific and sacred. Listening to the universe in silence and patience, like someone sending a message into the ocean and waiting for a reply. Yet the prolonged silence of the sky also plants a paradox within us. If intelligent life can arise in many places, why have we not seen any sign yet? This is the famous Fermi paradox. If the Milky Way has so many planets, why are we still alone? Perhaps life is rarer than we think, or civilizations are too short-lived to greet each other across the immense distances. Or perhaps they have existed but in forms too subtle for us to recognize. However, rather than pessimism, that paradox may be an invitation to look at Earth itself. For the silence of the universe makes us more aware of the fragility and preciousness of this planet. As we search for life out there, we also learn to cherish the life around us. The measurements of exoplanets not only broaden the horizons of science, but also reflect back the value of this small blue home where we were born. Perhaps one day, billions of years from now, we will receive a signal from a distant world. It could be just a simple sequence of radio pulses, or a complex sign depicting a civilization that has advanced far. That moment, if it comes, would mark a turning point in human history, making borders, conflicts, and divisions on Earth seem small in the face of a larger question. How shall we answer? But even if that never happens, the journey of searching is enough to shape us, for it forces us to place ourselves in a broader context, to see ourselves as part of a living universe. Looking up at the Milky Way, we see not only a band of light, but also an invisible network connecting billions of possibilities of life. We are not only asking about their existence, but also about ourselves, about the responsibility of a young civilization that carries within it the power to self-destruct or to mature and step into the cosmos. Science in this journey does not diminish the poetry of the Milky Way. On the contrary, it deepens it. Knowing that each star may have planets, we look at the sky and see not only light, but worlds we have never set foot on. Knowing that life may hide in subsurface oceans, we imagine creatures unknown, living beneath ice or within the clouds of giant planets. And knowing that intelligence may not be Earth's exclusive privilege, we feel connected to a far greater cosmic possibility. On a deeper level, the Drake equation and those searches out there also speak of hope. Hope that in the vast expanse, we are not entirely alone. Hope that even if humanity one day disappears, the story of cosmic intelligence will not end, but continue to be told by other civilizations. That hope is the very force that keeps us looking up, keeps us listening, keeps us dreaming. And perhaps that is the greatest value the Milky Way offers. It compels us to step beyond our narrow selves, reminding us that we are but a small fragment in the grand cosmic symphony. Within that fragment, we are given the chance to ask, to search, to imagine. Whether the answer comes or not, the very act of seeking is enough to make our existence meaningful. On the long journey of searching for life, perhaps the most haunting thing is the silence of the universe. The giant antennas of SETI have patiently pointed toward the sky for decades, listening to millions of radio signals, yet what we receive in return is only natural noise or faint pulses that then vanish. That silence is not simply the absence of sound, but an emptiness that makes humanity both anxious and fascinated. It could mean that we are truly alone, or it could simply be that we have not yet learned how to listen to the right melody the universe is playing. But it is precisely that silence that opens up another value. It makes us even more determined to deepen imagination and technology. From radio SETI, humanity expanded into optical SETI, searching for pure laser beams capable of crossing space. Then came the idea of seeking technosignatures, the accidental beacons of civilizations, such as the enormous heat emitted from a megastructure collecting energy around a star. Every hypothesis, every tool, every antenna erected is not only a scientific step forward, but also a symbol of the desire to communicate, the desire to prove that our existence is not merely a cosmic accident. Alongside SETI, other great eyes such as James Webb open another path, the search for biosignatures. When the light of a star passes through a planet's atmosphere, it carries with it a chemical signature. By analyzing those fragile streaks of light, scientists can detect the presence of oxygen, methane, water vapor, faint signals of life. Even the thought of it is breathtaking. One day, on the cold display of data, an atmospheric composition will appear that cannot exist without life maintaining it. That will be the moment humanity first knows that in the deep vastness, life has taken root on another world. What is strange is that even if we only discover microorganisms on a distant exoplanet, that discovery would still be enough to shift how we see ourselves. For it proves that life is not a singular phenomenon, but could be a universal law, emerging whenever the universe creates the right conditions. At that point, the greater question immediately arises. If simple life can sprout in many places, then is intelligence, the thing that allows humans to write music, paint, build telescopes, an inevitable branch, or just a rare exception? That question draws us back to the Drake equation and the Fermi paradox. If intelligence is common, why do we not hear them? Perhaps the vast distances cause faint signals to fade away. Perhaps civilizations exist only briefly, extinguished before they can meet. Or perhaps they have chosen silence, a deliberate silence, waiting for young species like us to mature on our own. Whatever the reason, that paradox is not only a scientific puzzle, but also a mirror reflecting ourselves. How long will we live, and how long can we keep the flame of civilization burning bright? While waiting for an answer, we may find comfort in the Milky Way, the vast home to which we belong. From Earth, looking up at the silver band across the sky, it is hard to imagine that each sparkling grain of dust is billions of stars, billions of chances for life. The spiral arm we inhabit is just a small branch, yet within that branch are the sun, the earth, and the entire story of humanity. Upon reflection, we realize our very existence is already a miracle of the galaxy, a rare result of billions of years of stellar evolution. Every atom in the human body was once forged in the furnaces of stars that died long ago. Every breath carries oxygen from leaves nourished by sunlight, from a star ordinary in the endless sea of stars. Placed in that grand picture, we are both laughably small and overwhelmingly great. For the universe has not only created life, but also a creature capable of looking back and questioning its own origin. It may take centuries more before we encounter a signal from another intelligence. We may never encounter one at all. But the search itself is enough to shape humanity. It drives technology, expands knowledge, and most importantly, forces us to ask about our own future. Will we become a civilization that knows how to cherish its home, to surpass limitations and endure for millions of years? Or will we be one of the short-lived civilizations, leaving behind only an empty slot in the Drake equation? And so the story of life out there is always intertwined with the story within ourselves. When we lift our eyes to the Milky Way, we are not only searching for them, but also searching for ourselves. That silver band is not a foreign spectacle, but a familiar place where every moment of human life has and will unfold. Every step of science, every dream, every longing for connection is a note in the galactic symphony that has been playing for billions of years. And perhaps that is the greatest thing. It does not matter whether we find them or not, but that we have learned how to walk, how to listen, how to imagine. In the vast darkness, human patience and hope are the light, a small light, but enough to prove that in this universe, there is at least one place where intelligence has ignited and longs to connect. When we think about the Milky Way, it is easy to see it as a giant painting hanging on the sky's dome. But in reality, it is not just a landscape to behold, but a vast ecosystem where everything is constantly in motion. Imagine a vast city where billions of houses shine brightly. Each star is a sun with its own worlds orbiting around it. In that city, we are just a small house on the outskirts, yet fortunate enough to live in a peaceful neighborhood, with the right conditions for life to emerge and grow. The stars in the Milky Way are like actors on an ancient stage. Some stars have just been born in the gentle cradle of nebula, radiating youthful and passionate light. Some stars have matured, steadfast and stable, shining upon their planets for billions of years. And there are stars nearing the end of their lives, exploding in a glorious moment before transforming into cosmic ashes. All those stellar lives follow one another, maintaining an endless cycle: birth, brilliance, dissolution, rebirth. That is not only the story of the stars, but also reflects our own life cycle. The miracle is that in the vast emptiness between stars, life still seeps through. Fine dust particles, seemingly meaningless at first glance, are the very foundation for future solar systems. Molecules of hydrogen, helium, carbon are quietly preparing to one day combine into planets, oceans, and even beings capable of dreaming and pondering. It can be said that the galaxy not only shelters us, but also writes the story of its own origin. The more we observe, the more we see that the Milky Way is not as still as we thought. It is rotating, flowing, constantly changing. The Earth and the entire solar system are rushing at hundreds of thousands of kilometers per hour around the center of the Milky Way on an orbit we have never completed. The interesting thing is that we do not feel this journey at all. Just like in life, there are silent movements that decide everything, things we rarely notice, but which are the very foundation of existence. And there is also a distant future awaiting. A few billion years from now, the Milky Way will merge with Andromeda. At that time, the current shape of the galaxy will change forever, but its legacy will continue in a new form. We, tiny human beings, will no longer exist to witness it. But knowing this in advance makes the present moment even more meaningful. We are living in a fleeting instant, yet a special one, because it belongs to us. When we look up at the night sky, we do not only see distant light, we see ourselves reflected within it, from the atoms in our bodies, from our warm breath, to our deepest thoughts. Every ray of light up there is a part of the grand story, and we too are a small chapter in the galactic epic.